Hello, everyone, and welcome. My name is Mark Boharnwa. Thank you for joining us for tonight's ASRC Falconer Lecture, the third in our summer 2022 series. Tonight's lecture, as you know, is Zoom only, and your video and audio have been disabled. If you have a question for our speaker, please type it into the Zoom chat feature, and we will address all questions during the Q&A session. It is now my pleasure to introduce Dr. Craig Ferguson, Research Associate at the Atmospheric Sciences Research Center, and Craig will introduce tonight's speaker. Craig?
Thanks, Mark, and good evening to everyone who's joining tonight's Ray Falconer Public Lecture Series, the third of the Summer 22 series. It's my pleasure to introduce Dr. Osvaldo Moraes tonight. He's the Acting Director of the Brazil Center for Monitoring of Natural Disasters, called CEMADEN. CEMADEN's mission is to monitor natural hazards in municipalities susceptible to natural disasters, as well as to conduct research and technological innovations that can contribute to the improvement of its early warning system. The organization operates an observational network, including weather radars, geotechnical sensors, and meteorological and hydrologic sensors. Dr. Moraes is past director of the Brazilian Center for Numerical Weather Prediction, and he's long serving as a professor in the physics department at the Federal University of Santa Maria, RS Brazil. Now, Dr. Moraes is no stranger to UAlbany and ASRC. He was a postdoctoral researcher visiting ASRC in 1990, from which time he began a long collaboration with ASRC Professor David Fitzgerald. That collaboration included co-investigation on a flux measuring project in the Amazon, termed the Large-Scale Biosphere-Atmosphere Project from 1998 to 2006, and also work in the Hudson Valley in the early 2000s, looking at shallow valley flows. So his research and his start in science focused on observational and theoretical aspects of boundary layer meteorology and fundamental description of atmospheric turbulence and surface fluxes. But he's transitioned from a very fundamental science career to now a more practical, societally beneficial position as director of CEMADEN, and he's served in this position since July of 2015. In his talk today, he will discuss the challenges he's faced over the past decade as he worked to implement CEMADEN's new early warning system in Brazil. So please join me in welcoming Dr. Osvaldo Moraes.
Well, do you hear me?
We can hear you fine. We can hear you fine, yes.
Okay, thank you. Well, thank you, Mark. Thank you, Craig. Thank you, David. It's an honor, it's a pleasure to be here again. Every time that I came to Albany, I have the opportunity to remember the days that I spent here and the very important cooperation that we had during a lot of years with David and the many Brazilian students and researchers that came to Albany. And so, again, it's my pleasure to be here again. And let me say thanks a lot for the invitation to describe how we are dealing in Brazil with the system to monitoring the hazards and to deliver early warning for the most vulnerable people that are living in Brazil. I will, before to describe what CEMADEN is and how we are doing our job, I will do some reflections regarding the disasters and the disaster risk reductions and the challenges for the science to dealing with disaster risk reduction. when we look events like this one, the first message that came to our mind is regarding the impact of the events. All of us stayed in shock a few days ago, looking the images associated with the flood in Kentucky, or with the wildfires in California. No doubt that the same shock was felt when we received the news of the flood in Germany in 2021, or of the Japan tsunami in 2011. But disasters are not events linked with developed countries. Of course, this is a joke. No doubt that the high impact of disasters is noted in developing countries. For instance, the WMO, in one report of the last year of the WMO, showed that disasters in developing countries account over 90% of fatalities due to extreme weather conditions. We may try to do a simple correlation to explain why the impact is higher in less developed countries. But this assumption is not so simple or direct. In general, we assume that all conditions going from resilience to infrastructure are considered crucial to mitigate the impacts of the threats. But that simple assumption relates impacts and the country development stage fall apart when we look at the COVID impact around the world. The most impacted country, considering deaths or infected people, was reported in the most developed country of the world. Then, going back to the previous simple assumption, how we can explain the COVID impact in the US. So there is no simple relation between development stage and the impact of disasters. The underlying causes for disaster risks are multiple. Values and norms, customs and cultures, religions, beliefs, societal divisions linked to issues, responsibilities, societal divisions linked to issues of inequality, terms of trade, of course, natural environment. According to the last data from the insurer Munich RA, this is an insurance that stays not in Germany, but in Sweden, losses from natural catastrophes in 2020 rose to more than 200 billion globally US dollars, from 150 billion in 2019. So from one year to another year, one increase of 25%. Disasters do not have an equal effect on everyone. Disasters and the conflict are mutually reinforced. Countries associated with fragility, conflict, and violence often face more intense risks from disasters because government capacity is debilitated. The lack of financial resilience mechanism for disasters often delays economic recovery and prolongs hardships from governments, households, business, and vulnerable conditions. So, in general, disaster risk and the impact of disaster is a combination of multiple factors. Disaster can strike at any time in any place, building slowly or occurring suddenly without warning. To reduce disaster risk, we must recognize and address complex links between natural and social systems, as well as technological and innovations. It's a common understanding that disaster risk reduction needs an holistic view that spans from treaties to local communities and the national security, as well that its impacts. The impacts of disaster is amplified by unsustainable development. For instance, David sent me one reporter from Washington Post in the weekend, reporting that the Department of Homeland Security in 2014 quadrennial Homeland Security Review identified 6 strategic challenges that it believes will drive risk facing the U.S. over the next several years. This reporter explained the process used by local communities in determining which of these threats have the greatest risk to their respective communities and how these communities prioritize their resources in attempt to prevent or mitigate these threats. And then Washington Post indicated that this plan should be adapted since more than 40% of Americans lived in a county that experienced recently a weather catastrophe with millions of America at risk losing their homes and livelihoods in natural disasters. The Post view opinion is that the U.S. disaster relief system was not built for our new climate. So the message now is that we need to consider not only the hazard, but also the changes in the hazard and the changes in the vulnerability, and also what we need from the engineers, from the technological, and from the social science to better dealing with the disaster risk reduction. The challenge for disaster risk reduction is so old, it's not new, that if we look what was the impact of disasters in the past, the data sets that are provided for research are so poor. There are no good data sets to investigate or to try to do correlation of how the intensity of the hazard and the impact of that. You have no good data regarding the improving or decrease or increase of the vulnerability system. And when we talk regarding the vulnerability, we are not talking only regarding the social vulnerability. So to do the science of disaster, there are no baseline or reference to do some comparisons. The data set that we use to try to correlate hazard and impacts are so poor. There are no good inference from data sets from economic and the other parameters. There is no time frame. We don't know, there is no protocol how you can standardize this data set. So from my perspective, the science of disaster is so new, and we need a lot of improvements to have a good improvement of the science of disasters. In this slide, I am trying to call the attention what is a disaster and what is a disaster risk. Disaster risk is the potential loss of life or something like that. So disaster risk is the probability of something will happen, while disaster is something that happened. But disaster is a concept. Disaster depends of the people that are dealing with disaster, while disaster risk is more something like with a definition. What I try to do here, what is a definition for in hard science? When we consider, for instance, the second law of Newton, F equal m mass versus acceleration, in fact, the second law of Newton is a way that we have to have a measurement of the mass of some object. If I have the force and I do a measure of the acceleration, I know what is the mass of that object. So this is a definition. In science, when you try to do the same, we consider, I will show in the next slide what I am trying to define as a disaster risk. But from the point of view of science, our challenge is that science needed to help not only the monitoring of the hazard, but to preparing for disaster, to how to respond to disaster, how to recover from disaster. So as I pointed before, as the climate is changing, and I have one disaster that impacts one road, for instance, how we need to reconstruct that road to avoid the same hazard in the future. So the science can help to do a better reconstruction of the structure that are affected by disasters. Well, then disaster, in considering the preparing for disaster, we need to understand what hazard is, what's the vulnerability, what is the exposure, who is exposed to the hazard, what's the vulnerability. And when we are talking regarding that, we are not talking only regarding the natural disasters, but there are other disasters that the people doesn't know that they are exposed, but they are at risk. So disaster can clarify, the science can clarify for each type of disaster, what is the hazard, what means vulnerability, what means exposure. The science can also help us to respond to disaster, how to planning, how to protect the people, how to protect the society, and even to recovery, how to build back better from a structure that was impacted by disaster. Now, for instance, disaster risk, this is one old view what disaster risk was. Until the 10 years before the Sendai framework, the disaster was considered more related with hazard. So, in the beginning of the science of disaster, all the questions that we are trying to answer is where is each type of hazard likely to be presented and why? What scientific principles govern the process responsible for the disaster? How often do these hazards develop in disaster? How can each type of disaster be predicted and or mitigated? So these are the questions, the basic question in the beginning of the science of disaster that we are trying to answer. But you need to remember that in the beginning of disaster science, all the people that are involved in that are people related with hard science. Social science is much more related with the response of the disaster and not with the beginning of the process of disaster. And then in the beginning, that was the main question that we needed to link: understanding, forecasting, and alerting. And if you look at these three questions, we see that they are common, for example, for atmospheric science. But disaster is not atmospheric science. Of course, that I needed to understand what type of data we needed to collect, how to forecasting, how to include emerging data in forecasting models in system, how to issue warning in face of uncertainties. So this is the oldest view of the disaster science. But now, I am now describing here what means the risk of disaster. The picture here is one picture of the Petrópolis. Petrópolis is a municipality in the Rio de Janeiro state. In the Petrópolis, there is a lot of neighborhoods like this one. So it's clear here that the vulnerable is present. Vulnerable in this place is constant. It is independent of the time. What is dependent of the time? Dependency of the time is the hazard. So the probability of the hazard is higher than 0 and low than 1. So have one hazard that the intensity of the hazard be higher than some threshold, the disaster will occur. Why? Because the vulnerability is present all the time. So if the vulnerability is present all the time and the hazard will be present sometime, then I have the disaster. This is the most innovative view to deal with disaster science and disaster risk. Nowadays, we know that the early warning system is not only to deliver the probability of the hazard. One early warning system, one complete early warning system, have 4 pillars. The first pillar is the risk acknowledgement. And when we talk risk acknowledgement, I am not talking regarding the risk, the knowledge of the hazard, but how the people that are living in risk areas know and have a perception of the risk that they are exposed. Monitoring and forecasting is only one pillar of this system. What we are doing in CEMADEM is this pillar. In CEMADEM, we are doing the monitoring and the forecasting of the probability of the disaster. But the other pillars, that means risk knowledge, information and communication, and the preparation and the response, is so important, like the monitoring and the forecasting. For instance, communication. What we understanding by communication? I can have an idea that communication is when I deliver, for instance, one early warning for the population. But if the population is not prepared to understand what I am saying, the answer of the population for that will be zero. So I needed to prepare the population to receive the early warning, to understand the early warning, and to be prepared to take action. And also, when I deliver one early warning, I needed to do some indication what action the civil defense needed to be prepared to act during the disaster time. This is the same slide, but having another point of view, not only for one specific disaster, but to a chain of disaster, one multi-hazard early warning system. This is a new view that was approved by the UNDRR. UNDRR is the agency, the office of the UN for disaster risk reduction. And the UN approved recently this new view of what is the multi-hazard early warning system. But this is more or less the same that the previous slide. You needed to have one disaster risk knowledge, detection, monitoring, analysis, forecasting, deliver the early warning, how to communicate, and on the other side, how to prepare it to respond for the disaster risk. So disaster risk, one early warning system for disaster is one complex system. Is not only doing monitoring and to deliver the probability of the hazard. What means risk knowledge? Risk knowledge means vulnerability, assessment of vulnerability, hazard maps availability, land use, population, financial value, and so on. Monitoring and forecasting includes observation, models, and forecasts. Communication is how to connect people, how to connect families, how to connect family communities. And the preparation and the response capabilities range from individuals level activities to household actions, community, and governmental efforts. So disaster risk reduction is one initiative that depends for multiple actors. If some part of this chain is not working properly, probably the impact of disaster will be higher. Well, recently the UNDRR, that agency from UN for disaster risk reduction, and the International Science Council created one work group to review all terminology of hazard that we had before. Until 2019, there is a lot of terminology for different hazards with different names. Nowadays, we have one cluster of disasters that was approved by the UN that considers the hazard types divided by the meteorological and the hydrological, extraterrestrial, geohazard, environmental, chemical, biological, technological, and social hazard. So you have nowadays 7 clusters of hazards that you can do some examples, some studies that you don't have before. Where I came here. Well, just some examples. Environmental hazard, for example, deforestation is one hazard, wildfires, desertification, chemical, mercury, pesticides, biological, blood-borne viruses, cholera, technological, bridge failure, dam failure, building collapse, and so on. And the most important, recently, the UNDRR adopted another cluster of hazard, the social hazard. Until that, social hazard was considered vulnerability, but nowadays, the UN considered that, for instance, violence, financial shock, no international armed conflict are also a hazard. This is another interesting example of hazard. No, you can see 3 different examples. For instance, vulnerability in general is present in permanent way, but in some parts of the world, to be female is recognized as a powerful, resilient, and recipient of the same respect that is given to a man. But if you live in developing country across Asia or Africa, to be female could be you are hungry, even though you are in charge of your household food production. To be female may mean you are a farmer who lacks access to the same work tools or land right as your male counterpart. So this type of hazard is so important because this is a culture hazard. Consider one female that lives in that condition. During a disaster, these people, this part of the human being are most vulnerable than men, the counterpart. Another hazard that you don't consider very well, you don't consider frequently, is the economic hazard. This example, the Lehman Brothers, do you remember that? The Lehman Brothers filed in 2008, hundreds of employees left their jobs. At that time, the collapse of the Lehman was the 4th largest investment bank in the United States. The collapse of that bank produced one large-scale disaster during a lot of the different parts of the world. This is another type of hazard. And do you remember also the 3 Mile Island, the technological vulnerability in this nuclear power plant in US? So in general, hazard is not only the natural hazard that the atmospheric science consider. There is another type of hazard that you need to take into account to have a better preparation for disaster risk reduction. So now I will briefly to describe, have this broad overview what disaster risk is, what CEMADEM is doing, and how CEMADEM is doing. CEMADEM was designed considering 3 pillars. One is the mapping of risky areas in Brazil for landslides and flash floods and flash floods. The second pillar is the observational network that we are using to monitor the hazard. And the 3rd pillar is the profile of human resources that are working in CEMADEM. CEMADEM is not a meteorological center. CEMADEM is a center that is dealing with monitoring the hazard and deliver information for the population. Of course, that the weather forecast is important for us, but we need other type of information to deliver early warning. So this is more or less the conception, the conception of the structure of CEMADEM. Well, you can see here what is the underlying process for disaster in Brazil. In Brazil, over 10 million people, mostly poor and vulnerable, living in susceptible areas like this one. This is a picture of a favela in Rio de Janeiro. In Rio de Janeiro, there are more than 400,000 homes like this one. And so this is a permanent vulnerable area. When I have one hazard with a value higher than some threshold, what will be happening is that is showed in the picture on the other side. So the vulnerability is here, the vulnerability is present. So SEMADEM, to deliver one early warning, consider the profile of the population that is living in this in a place like this one. In Rio de Janeiro, this is another data from the number of houses in favelas in Brazil. In Rio de Janeiro, São Paulo, Salvador, and so on. In Salvador, there are more than 400,000 of houses like this one. In São Paulo, more than 300,000 like this one, and so on. So the picture for the disaster is ready. So it's only waiting. The picture for the disaster is ready. So it's only waiting for the presence of the hazard. In Brazil, this is information of the percentage of reported people affected by disaster. Landslides and the flash floods account for more than 90% of fatalities, while droughts accounted by more than 50% of the people that are infected by disaster are infected by drought. So SEMADEM is dealing only with landslides, flash floods, and impact of drought. We only deliver early warning for this type of disaster. Why? Because these disasters are the disasters that more cause fatalities in Brazil. But at the same time, another important point to be considered that for floods, landslide, I can have you an idea of the risk area. For one tornado, for instance, I can't do a prior one idea what will be the risky area, the exactly risky area for the tornado. But for the landslide, I can have you an idea about that. So in this picture, I am showing to you the Rio de Janeiro municipality and all risky areas in that municipality susceptible to landslides. Each color in this polygon are related with the index of social vulnerability for that. In red are part of the people that has high, very high vulnerability index. In orange, people that has high vulnerability index. And in yellow, medium vulnerability index. So when SEMADEM deliver one early warning, we need to take into account the information and the vulnerability for each risky areas. When, for instance, when we deliver one early warning for the Rio de Janeiro, we are not considering the people that are living in Copacabana Beach, because in Copacabana Beach, there are no susceptibility area for landslide, for instance. But for the favelas, the susceptibility exists. So we deliver early warning for these risky areas. We do not deliver early warning for all the municipalities. Why we decided regarding the index of the vulnerability? The index of the vulnerability was calculated considering some data of the people that are living in each risky area. For instance, how many women, how many elders, how many disabled people are there, how is the incoming, the medium incoming, how is the medium level of scholars, and so on. Using a lot of data, we created one index to define the vulnerability, the social vulnerability index for each risk area. Well, this is the common procedure that we have to deliver one early warning. The first one is to have one idea regarding the weather forecast and what is going on just now. Having that idea, we procedure for one hydrological process or for one geotechnical process. And then we can have one construction of the risk scenario for the physical event, for one flood, for one landslide, for instance. And then consider the index of the vulnerability. We have the construction of the risk scenario for the impact. So the early warning of the CEMADEM is starting looking the weather forecast, the situation just now, and then to consider the probability of the physical event and where this physical event will happen, and then we match that information with the vulnerability of the people that are in risk areas. But consider this example. 4 weeks ago, we have one huge disaster in Recife. Recife is the capital of Pernambuco state that is located in the northeast of Brazil. We delivered this early warning with 40 days of advance of the disaster. And the early warning, when it was open, it has one level of very high. It means the event will happen. At that time, 48 hours in advance, when CEMADEM delivered the early warning, we are sure that the disaster will be occurred. And we informed for the civil defense how many people can be affected, how many houses can be affected, the places of the city that can be affected. This was done with 48 hours in advance. However, the number of the deaths was so high. In other words, having the early warning is not sufficient to protect the people. Doing the best job that we can do, doing the monitoring, deliver early warning, timely, in advance, correctly for the place of the city where the impact will occur, it doesn't avoid the impact of the disaster. So the final question is, would the death toll be higher if the early warning had not been sent, or is the early warning alone is sufficient to mitigate the impact? So I have no doubt that the vulnerable is the most important part for disaster risk reduction. Monitoring and forecasting of the hazard is important, no doubt regarding that. But the vulnerability, for me, nowadays, I believe that is the most important part to consider for disaster risk reduction. Well, I finish here. This is just to finish. As I said before, in Recife, there are near 600 risk areas. and the more than 200,000 people living in this risky area. 71% of the population in these risky areas has very high social vulnerability index. So for me, this a definition so clear that the vulnerable is the most important part for disaster risk reduction. Thanks for your attention.